Welcome to Access Control, a podcast providing practical security advice for startups, advice from people who've been there. Each episode will interview a leader in their field and learn best practices and practical tips for securing your org. For today's episode, I'll be talking to LVH. LVH is a principal and co-founder of Latacora. Latacora is a security consultancy that's focused on creating security practice and maturing in-house capabilities. Teleport has been partnering with Latacora for a number of years, and we found that their process and insights valuable as we've grown. I was fortunate enough to work in the same office as LVH during my time at Rackspace. Along with enjoying LVH's Hack Day projects, I always learned a lot about new security and encryption technologies. LVH, thanks for joining us today.
Thanks for having me.
To kick things off, can you tell me what it means to have a security practice in a startup?
Great question. So I think one of the original challenges that we saw when we started Latacora is that there's lots of startups who are trying to do security things. For many of them, that might mean I'm going to go get a pen test, right? For many of them, unfortunately, you go look at that pen test and the results, the impact on security for that company, you go look a year later, it's not necessarily that valuable. And I don't think that's an intrinsic problem with pen tests. I think that's an intrinsic problem with the context of the pen test. Because if you go look at a large mature organization with a large mature security organization or a large security practice, they're going to be looking at pen tests in a completely different way. It's not the entirety of their security practice. They're looking at a pen test almost in the sense of like hypothesis validation. It's like I have this idea of what might be wrong, and I'm going to ask a third party to go double check and go make sure that I have I have a decent handle on that. And so as a consequence, you can't really expect to get the same results if you just copy the I'm doing the pen testy part, but not do the rest of the proverbial owl. The idea behind running a security practice, I mean, it's very broad, but effectively it is identify and then mitigate risk for the company. What does that mean? Well, that can take a lot of angles, which is one of the reasons why I think it's very challenging for individuals to do that. One of the harder jobs in security is go be the first security person at a startup. It's not because people are just not capable or something. It's because one of the issues is we say security person at a startup, but what does that mean? Like startups don't have a security person problem. They have an application security problem on Monday. They have a cloud security problem on Tuesday. They have an IT security problem on Wednesday. They have a compliance problem on Thursday. A network security problem on Friday, right? And I say application security as if that's one field. The person who is going to be competent at auditing your web front end or your mobile application, or in the case of Teleport, a bunch of Go backend services with fairly complex cryptography going on. They're all different people, right? And you can't reasonably expect, you might be able to get like one or two expertises. If you're really lucky, you're going to get 3 or 4, but you can't reasonably expect someone to cover all of those fields. Like there's nobody who's going to be excellent at, AWS and Azure and GCP and also knows everything that there is to know about SOC 2 and HIPAA and, whatever it might be. And not every startup is going to need every one of those. You could hire the world's best Kubernetes security expert. The day that you have an Android security problem, it doesn't really help you. I guess I didn't really answer your question directly, but the idea behind it, what is a security practice that identifies and mitigates risk for an organization? What does that mean specifically for us? I mean, we do that for startups. So we're going to be doing startup looking things, right? Like we're going to be doing that on AWS most of the time, or at least on a major cloud provider. We're going to be doing that typically with reasonably modern languages. Most of our customers are on, Python or Go or something, et cetera, et cetera.
And then is there a stage in which people come to you? There's sort of an inflection point. They're like, okay, I understand what security practice is. I need to bring on an external party. At what point do you see people sort of picking up the phone?
It used to be the case that we started working with people where the low watermark was about 12 engineers. And the reason for that is mostly that because Latacora's remit is so broad, it has a tendency to expand horizontally. And by which I mean, for example, we have a compliance practice, and we have a cloud security practice, and we have an AppSec practice, et cetera, et cetera. And there's no particular reason why a new practice wouldn't exist. So it tends to expand a little bit. And as a consequence, there's a minimum viable team on the other end to be able to just drink from the fire hose. And it was always really hard to kind of pick, like, could we have done a smaller version that only did AppSec? Yeah, but then we only did AppSec. And the problem that we wanted to solve was go do security services for startups, like go build security practices for startups. And so you can't do that by only caring about AppSec. And so it tend to naturally expand. What we've been doing I want to say that we've been building it out maybe for the last year or so, is a program that we call Latticora Jumpstart, where we're working with far smaller customers. So the smallest customer that we started with, I believe they had 3 people when we started. And there we're really focused on like just the advisory work, and then all of the stuff that we have tooling for in the background, because it's relatively easy. Like, it's expensive for us to maintain and develop, but it's reasonably economical for us to go run for an extra customer. And then really just focusing on the advisory work, because they're still building the app. So doing a full bore assessment for 6 weeks, like, is kind of pointless, because I'm going to be looking at a bunch of code that's not going to exist a year from now, and helping customers build that. And the one thing I've been surprised about with Latticora is the range. We started at like the 15 people. We had a couple of companies go public under our watch, which I would not have ever believed if you told me that when we started. It's a pretty broad range. I would say that if you're trying to hire a security person, the industry standard ratio seems to be somewhere like 1 in 25 to 1 in 50, depending on like how security sensitive and how tightly regulated you are. Of course, you have all the aforementioned problems of which security person are you going to hire. Sort of like the minimum viable security set might be, I don't know, 3 or 4.
So for people who are thinking of hiring someone, and especially bringing in external consultants, what sort of questions do you look for them to ask when they're just bringing you on board?
So I can tell you what makes an easy Latticora customer, which is a slightly different interpretation of the question. But because our remit is so broad, we're trying to find the commonalities between customers and then like exploit those mercilessly. And therefore, it's like AWS, right? And if somebody came to us with Oracle Cloud, I'm not saying that I have a problem with Oracle Cloud. I'm saying I don't have enough Oracle Cloud customers to warrant building a Oracle Cloud practice internally, right?
Yeah.
And so similarly, GitHub, right? Like if you're using Perforce, fortunately startups don't use a lot of Perforce, but like if you're using Perforce, then I don't have a way to engage with that. And same thing with Slack, same thing with Google Workspaces as opposed to Office 365, something like that. When you're evaluating a consultant, what sort of things should people ask? There's definitely some services out there that I have some questions about. And I think one of the bigger ones are, like what's the breadth of services that you're offering? And then the second part is, what does that billing model look like? Because one of the flaws that we've seen with customers, Latticora is flat rate. The reason that it's flat rate is because I never want to be responsible when somebody decided that a particular feature is like, is this dangerous? Is this not dangerous? Well, I don't know, but I'm not going to spend 10 grand to find out. But the benefit of having us, like we're a lot of what we do is modeled after the sort of like perfect mythical unicorn security person that was able to do everything, like all those fields. Obviously, we're a service, so we get to cheat a little bit on the inside. We don't have a lot of unicorns. And so we kind of spread the load across those. I would say that be very careful about what the things are that a service is allegedly good at. And there's plenty of, there's nothing wrong with someone just being a compliance person, right? Like there's nothing, like if you need compliance, go do compliance, right? Like there's so many companies, especially these days, like SOC 2 is table stakes for so many enterprise deals, like even smaller and smaller business to business deals. There's nothing wrong with just going to go get your SOC 2. I would generally say that most security services are designed by and for security people and for security people at large companies. I do have my doubts that, let me put it this way. Let's say that you buy EDR, Enterprise Detection and Response thing. They're going to go install a bunch of agents on all your endpoints and a bunch of log management, and it's going to go back to their SIM, and they're going to do all sorts of analysis on that and maybe alert you. If you don't have a security practice internally, what are you going to do with that information, right? Like if you don't have someone who is also doing the work to make sure that, I don't want to say full beyond corp, is also doing the work that you could reasonably lock out. Let's say the machine's compromised. Okay, what do you do? Right? Like if you don't have the security practice to make sure that you could reasonably effectively action on that information, then congratulations, you just paid a bunch of money for a thing that just gives you anxiety. The only thing worse than not getting alerts is getting alerts. And like, that doesn't seem useful. And keep in mind, I'm not saying EDR is bad, right? Like EDR, there's classes of companies for whom EDR is great. I just don't think it should be your first security purchase. And same thing as like, buying your own SIM. Like I think that's a really questionable expenditure. There's this like bathtub curve of value provided. The first couple of dollars that you spend on a SIM are fantastic, right? Like the first time that you go from no visibility to, minimum viable visibility, that's fantastic. And then there's a giant chasm of Splunk spend where you're not, and I'm not trying to rant about Splunk, right? Like Splunk is a fantastic tool. They're one of the best in the industry, but like you could spend so much money on Splunk and get zero freaking value out of it. I see plenty of startups do that. And so like you got to have the backing, right? You need like a senior security leader to go build out the program so that it makes sense for you to have a Splunk and that you have something for that to plug into and go affect organizational change. Because if it's just a thing that produces Slack alerts, then, I mean, I don't know, you could do that yourself. You don't have to spend money on anything.
Once you start an engagement, what are some of the first things you look out for?
We start by doing what we call a security architecture review, where we basically just interview everyone. Because one of the observations is that a lot of the audits are designed to be, and so like they're audits, they're intentionally validating. But one of the things that we found is like, I'm not saying that's not useful, but it's useful in a different context. It's useful for the hypothesis validation that I hinted at earlier. We just interview a bunch of people to begin with and just ask them questions like, what's keeping you up at night, right? Like, what's the code that you're worried about? We've got like a whole host of questions across like application, from really high level stuff. Who are your users, right? Like if you had to describe to me, like who are the stakeholders? And who cares that this entire application even exists? Walk me through that. What do they do with this? How do they engage with it? All the way down to like pretty detailed stuff like, can you give me a reasonable description why you think that you're not vulnerable to I don't know, systemic server-side request forgery attacks, right? And the answer might be, we don't have a webhook functionality or anything like that, or it might be like, we deployed smokescreen, or like, I don't care what the answer is necessarily, but we're trying to figure out like across a super broad set of things, including mobile device management, like bring your own device, or are they like, tightly locked down Chromebooks or something in between? And so we're trying to do like a super broad assessment across all of those. And there are parts of that we're going to be able to, either we have to validate because the client might not know. So for example, we started asking, are you using multiple AWS accounts when AWS organizations was still super new and almost nobody was using it. And so a lot of clients were like, I didn't realize that. I suppose that's possible, but I don't think so. There are things that we have to go like validate, like did anyone actually do that? Same thing on the OPSEC side, same thing on the CorpSec side, but most of it is really just asking questions because it's not an adversarial setting. Nobody's trying to swindle me into believing that your security practice is better than it is. Kind of like lying to your lawyer or lying to your doctor. Like it's not exactly a plan for success. And so that's kind of how we start. And that gives us like, that informs the roadmap. And then from the roadmap, we start doing things like, hey, let's do an application security assessment. We did a bunch recently for Teleport. Or, let's go, I mentioned application security assessment. It's not the only one. Like, do a cloud security assessment. Let's go, you've got this many apps with this many permissions in your Google workspaces. Let's go get that number down, that sort of thing. But then the point is like, it's informed by a business risk, right? Like I could just randomly go do that. Or I could say, hey, sounds like Google Drive is super important for you. Tons of super sensitive information is in there. It sounds like I should be going through that with a fine-tooth comb. Different customer might barely use Google Drive and like doesn't really care to barely use Gmail. They're lucky if they use the calendar once a week. And like, okay, great. Maybe I'm not that worried about how many authorized apps you got.
This is a good segue into a post you shared with me, which is the SOC 2 starting 7. And I think it covered a bunch of key areas for also sort of compliance and the SOC 2 process, and things that which are not necessarily security, they're more compliance. We can probably like touch on all 7 of them, but just to give people a high level, like what exactly is SOC 2 for people who aren't familiar?
SOC 2 is a auditing standard, or an audit that people use the term to mean slightly different but related things. So typically when a company talks about their SOC 2, they're talking about their SOC 2 audit, meaning either a type 1, which is a point in time assessment of the organization, and a type 2, which is covering a larger amount of time. Historically, that's always been a year, but these days, we've seen 6 months, 9 months, even 3 months. The way that I would describe SOC 2 in the minimum number of words is, do you do what you say, and do you say what you do? So the idea is, do you have policy work that reasonably describes what you actually go do? And then do you actually go do those things? And where possible, do you have evidence to prove that you're actually doing those things? One of the things that people don't always get about SOC 2 is like, I feel like SOC 2 has gotten a little bit of people say it with some fear in their voices sometimes, I get the impression. And I understand why, because like if they were to somehow miss out on it, like if you're a B2B SaaS, like that's, I don't want to say a death sentence, but like it's really hard to sell without getting a SOC 2. I think part of that is because it's become so commoditized. Like even 5 years ago when we were starting Lanacora, I feel like SOC 2 was, if you sold to a major financial institution, you cared about SOC 2, maybe. One of the interesting things is SOC 2 is issued by the AICPA, like the Organization of Yes, of tax accountants, which, it sort of makes sense if you consider, obviously there are forensic accountants who are trying to find fraud. And so they're used to this concept of auditing, but it's still kind of interesting that your SOC 2 is they're a CPA. They can technically do your taxes. They're probably more specialized than that, but technically, regardless, it really doesn't say a lot. Right? Like SOC 2 is not, and I don't mean this in a bad way, like it's not that high a bar. It really just says, have you thought about what you do? Do you say what you do? And do you then prove that you actually do that thing? Right? For that reason, I would say that, I don't think that SOC 2 is that, I don't want to say that hard. Like it's not like it takes no effort at all, but it's a reasonably low bar. And if you do it well, the thing that I always find, maybe not frustrating, but certainly a missed opportunity. There's this like historical divide sometimes between compliance people and security people, or compliance people and developers, where it's like, developers like, why are you making me write down all this like encryption policy stuff? I'm going to go do good things. Why can't you just trust me to do my job? And the answer is because lots of people screw it up, and you might not have thought about this as much as because you think you're going to do a good job, but like, have you actually thought about what you're doing and why? And have you then written that down? And like, when you say, I'm only going to use AES 256 GCL, this is one of my favorite examples. Some of the people that we've heard, I think twice, maybe 3 times, where somebody had they eventually got the report, because the report, SOC 2 report, does not mean pass with flying colors. There's 3 levels, and the words are escaping me right now, but it's basically like, pass with no comments, pass with comments, fail. You have to pull some to fail, pretty much do an outright fraud. Like you would know if you were going to fail. Most of them are just pass with no comments because they end up getting, remediated during either SOC 2 prep or during the type 1. Sometimes there is pass with comments. Really, the bar that's being set there is relatively low. So there's pretty much 2 standards that that are relevant here. There's the TSC, SSAE 18. Honestly, for compliance documents, they're relatively they're not like impenetrable. You could go read them. You could reasonably learn something from them. The vast majority of the time, though, they describe some organizational controls. They describe a handful of technical controls. Like I think it's the TSC that mandates anti-malware, for example. The level of specificity, I think a technical person would not describe those controls as specific. Right? It's just saying you need some anti-malware. Like, okay, well, I got a bunch of Windows machines. They're running Windows Defender. Yeah. Is that not anti-malware? I think it's anti-malware. It's described as anti-malware. And if you're even running a Mac, that's where it gets weird. Lots of people buy, anti-malware software or antivirus for Mac because Macs don't come with antivirus. And that's not really true. There's Xprotect, which Apple bills as anti-malware, right? It's, if Windows Defender counts, Xprotect definitely counts. And so there's little things like that. You effectively write down what your controls are. An auditor will go through them with you, will review them, make sure that they're, if they're auditing to a specific standard, which almost always is going to be a combination of TSC and SSA 18. Technically, you don't have to, but that's de facto what happens, at least for smaller organizations. They're going to come back and say hey, give me evidence for controls X, Y, Z, and the other thing. And so, for example, you might say, we will check out our cloud infrastructure and audit it against common known misconfigurations. And we will do so on a weekly basis or something. And then your auditor will say, great, prove that you did it on a weekly basis. And the evidence for that can be really broad, right? Because at that point, you're talking to a human, right? You just pretty much have to convince the auditor that they're going to sign their name to something that is reasonably descriptive of reality. If you say yeah, we've got this bot, it runs, it dumps some stuff into Slack. It's happening on a weekly basis. Let's scroll up and that's fine, right? There's no specific technologies that you need, or you don't need endpoint monitoring, or there's tons of stuff that I've heard people say. One of my favorite ones was, hey, the client asks us, what do you like for host intrusion detection systems? And I'm like, I'm sorry, I don't like any host intrusion detection system. Why would you ever like that? Why would you ever? In the context of this particular customer, it really made no sense for them to deploy HIDs. I'm not, casting aspersions generally in the direction of HIDS. And it turns out that it was literally just a misunderstanding with their auditor, where their auditor was says here you got this document with inventory. It says you got a bunch of hosts. It says here that you're going to do something to do intrusion detection, that you're going to detect intrusions for them. And it's an MTDR and an MTDD. So therefore it stands to reason you need some kind of system to detect the intrusion on the host. And so like literally they just like stumbled on host intrusion detection system, not realizing that it was a term of art, and like, me nearly blowing a vein in my forehead. Turns out it was fine. They ended up having intrusion detection systems that were to the auditor's satisfaction. But that's really common for SOC 2. Auditors will say a thing, it will get interpreted very literally, and it's not necessarily the thing that is actually required. It could be that same auditor, like last week, was working on an organization like 1,000 times the size, or last week they were working on a grocery store, right? Like, and the controls that they come up with are completely different and make no sense for that particular organization. So there's a little bit of care and feeding to that process.
Yeah. So your blog post covers these sort of 7, I think they're like just great best practices for any organization. And I think the thing that's sort of interesting is it sort of covers a lot of, in at least the world of teleport, like actually just IT administration. It's not a developer or cryptography or what you'd necessarily think of as traditional security.
Yeah, I'd say that's fair. And I think part of the reason for that is that because SOC 2 is coming, SOC 2 is a compliance standard, and a lot of the compliance standards are focused on, what are people going to do? Like, what sort of access control mechanisms do you have? Like, how do you know that is actually happening? As a consequence, a lot of the controls end up being more in what you might call the IT space. So we actually have a fully fledged pillar of so we've got application security, SecOps, which is, cloud security, and a couple of other things. What we call CorpSec, corporate security, which is mostly like IT, so mobile device management security, and managing Google Auth and et cetera, et cetera. As a security person, I would love to be known for the ninja alien space hacker wizard vulnerabilities that we find, but the truth of the matter is that I think by body count, CorpSec might be leading, because they just find a lot of the problems that they find just end up being like these company ending events for what feels like a relatively minor misconfiguration, going from, like, for example, in the AppSec side, let's say that we find like cross-site scripting, right? Is that bad? Sure. I mean, depends on context. Sometimes it might not be pretty much nothing, but we'll find this bug and like, okay, fine, you fix it. But like it's pretty difficult to go from cross-site scripting vulnerability to startup is over now. Whereas, for example, one of my favorite bugs that CorpSec keeps finding is like a self-service Google group that allows you to like add yourself to that. And then there is critical third-party service that is only protected by a password, and they have an account recovery process involving that group. And so you add yourself to that, and suddenly you have like escalated privileges like that. That one we found way worse, like in terms of actually company impact. And then to your point, a lot of it is just really important from a compliance, like from a GRC, so from a governance, compliance, and regulatory perspective. And it ends up being really helpful. And so we have a full-time compliance person who actually started their career as an applications, like as a security engineer. Like they're like properly technical. Then they went on to solving a really hairy compliance problem, and now they do that for our customers.
I think one thing that stood out to me on this blog post as far as recommendation was, I think 2 recommendations. One is using multiple AWS accounts, and the second one is making sure CloudTrail is turned on and use assume role. Can you sort of say why those 2 things are so important for many startups who run on AWS?
The main reason behind the multiple accounts thing is that because we found that in many cases, it's really hard to get people to like do a great job at managing AWS IAM. Like it's for like people just like write a particular permission. It's super broad, and then they just keep adding infrastructure and infrastructure and infrastructure. And before you know it, that ability to read from every S3 bucket is suddenly far more terrifying than it was when you agreed to it. Add to that the tooling within AWS for minimizing your permissions is nowhere near as mature as it is in, if you go look at GCP. GCP decided to do a very good job at solving a simpler problem, and AWS, has taken much longer to solve a much harder problem. By which I mean, the GCP, because the AWS gives you far more granularity for expressing. Like there are plenty of very granular IAM constraints that you can express in AWS that GCP just has no option for at all. And so when I say, GCP has like a button you can log in, I'm sure anyone who's used GCP for any amount of time, logged in, looked at, the IAM, there's a button there that says like, remove, I forget what it says, like remove permissions or something. It's like, it's very, very user-friendly. It's very hard to miss, honestly. And part of the reason they can do that is simply because they have fewer permissions and like they have a far less complex constellation. One particularly hard boundary for AWS IAM is multiple accounts. And we found that like it's a very good sort of first pass where, give your engineer, like if your engineers want to mess with a particular service, great, give them an AWS account, right? Like it's reasonably well sandboxed. Doesn't really matter if, if you're clicking around in the AWS console and it tells you it's making like, I'm just going to create this one cluster. Like, yeah, no, you created a cluster and a VPC and a security group and like 5 IAM roles and like you created a bunch of stuff. And I don't have, mastery over everything that just got created. So it's also pretty hard to go tear down again. But the wizard is it's user friendly enough. Like you can't just tell someone like you're not allowed to mess with a service until it's fully terraformed. You basically just told them not to go mess with services. And so we think that AWS accounts are a really, really fruitful way to get just like a super basic, almost like a product level or like a like per engineer or, dividing dev and prod. And conveniently, it means that you don't have to do a ton of work now because you're already thinking about like, hopefully you're thinking about whether you're in dev or prod before you drop the tables. So you're already thinking about that. So it's not like that much of an extra, it's not much extra mental bandwidth that's being asked for. But then on the flip side, from a security perspective, I have an extremely strong guarantee that things are going to stay separate. And similarly, if an auditor comes and asks, then we can say, we don't have to spend hours talking about AWS IAM policies. We can just say, separate accounts, like completely separate auth domains. Like it's not even a problem. So it's just a question of how much value do you get for how much work you have to put into it. And multiple AWS accounts is such a no-brainer.
For the prod account, I think we do this, that we always, if you use assume role, you get more audit events as opposed to a shared login or other.
There's a bunch of reasons for why we like assume role. So one of them is one problem is if you're using AWS access keys directly, then they're somewhat necessarily in your home directory, generally in plain text. I know you mentioned you'd like to talk about supply chain attacks at some point, so I'll try and leave that one for a little bit later. To your point, you mentioned that you get more audit events. That is certainly true. Particularly, it becomes easier to start doing the IAM minimization down the road. Because one of the things, like back when the Segment blog, before they got acquired, they had these wonderful articles about their AWS environment. And their AWS environment was a thing of beauty. I'm sorry, I say was. I assume it still is. They were doing all of these super great things. But one of the challenges with it is that they're showing you the end state, right? And I get why. That's not criticism, right? I get why they're showing you the end state. They want to entice people to come work at Segment, and like it was pretty effective. The thing that they're not talking about is or very often, is how do you get there, right? Like what are the minimal viable things that I have to go do along the path that I can plausibly go get engineers to do tomorrow that are going to materially mitigate risk? Account separation, fantastic first example. Assume role is the next step. Why? Because if you've got a bunch of roles that you're using reasonably judiciously, even if you're assigning all of them star, just by the fact that you're separating them out and they have a name that I can go reason about, then it becomes a lot easier down the line. You don't have to make all of the decisions and know what every single person in your company ever needs. You could either, you can go do that down the line. You can do that one at a time. Project where we're doing analysis on CloudTrail in order to like infer similar to what GCP is doing, like infer what the permissions ought to be. And you can do all of those things, but you don't have to do them today, right? And so a lot of our programs are kind of like set up so that you got to start somewhere, right? And like if you start by looking at like, look what Segment has, then I think it's really likely that you just sort of give up because, it takes a while to get there. It's a really impressive setup.
I'll have to look that up. Shifting gears to another one of the starting 7, you kind of mentioned vendor sec. And I think the thing that sort of piqued my interest in this is how you talked about even possibly evaluating which Chrome extensions can do certain things on the DOM, which was sort of a more fine-grained review than I've seen previously. Can you talk about what vendors you look out for and things you might think, that's a bit suspicious?
It is definitely true that our vendor sec process is more in depth than a lot of others. So for example, we found like SAML bugs, vendors for clients, and I doubt that the median vendor sec process involves auditing for SAML bugs. That said, for the web extension one, that one's actually reasonably easy. So there's a tool called CR Excavator, and because CRX is the Chrome extension, extension. So if you were to ship a Chrome extension, it would be in a file, and that file would be called a CRX file. So CRX, and if you've never written a Chrome extension before, the access that the Chrome extension has is described in a file called manifest.json, which exists in the top level of that, internally it's a zip file. You can just simply inspect that and then know if I allow this Chrome extension, then it's going to have effectively cross-site scripting on every website. It's going to be, that's the default, like the star permission is basically on every origin, give me the permission to inject code, which at the end of the day is what a cross-site scripting attack is all about. There are mitigations though. So like, for example, there are some extensions that I'm not comfortable running in my production Chrome profile. So I have a separate Chrome profile that I just use for, that. And there might be there's like a video downloader extension or something.
Yeah.
And so because it works on pretty much everything that uses the video, the video tag, it tries to have access on every page. And I'm not giving it access to, a lot of Quora Slack.
Knew someone who had a social sharing web extension that was very popular, and they made money by rewriting everyone's links to Amazon affiliates back when this was a possible thing.
That
to show you some of the, and that's not great if you can rewrite a link.
So a Chrome extension can do pretty much anything that Chrome can.
Another thing that kind of comes up a few times is it risky to run 1Password Chrome extension, or is it better to use the Mac app or just use it on your phone?
That's a rough one. So it's not near the top of my list of things that I'm super worried about. That said, I don't run the Chrome extension. So I run, this is not necessarily an endorsement, but for what it's worth, I do two things. I use Chrome's built-in password manager combined with Pass on the CLI, which is just a command line password manager. It's not, not particularly fancy. It does what it says on the tin, and I move on with my life.
I guess talking about secrets, another thing you recommend is using AWS Vault, which I think is a project from
99 Designs.
99 Designs, yeah. Describe this project.
Yeah, absolutely. So AWS Volts is so it's 99 Designs / AWS-Volt on GitHub, and it's effectively it's a stepping stone. It's a perfect example of that, slowly improving your IAM practice thing that I was mentioning, because it's a stepping stone where it's really easy to get started. What it does is it takes your existing AWS access key ID, so the thing that starts with AKIA and your secret, and it puts it into the closest equivalent to your operating system's keychain. So if you're on macOS, it's literally keychain. And then what it does is when you can use it to assume roles, which I recommend that you always do, because there's a weird little pitfall if you're not using roles that I won't go into too deep. But then in order to go use that credential, what you do is AWS Vaults exec name of a particular AWS profile, which typically maps to a role. And then you do -- AWS STS get caller identity, which is the AWS command for tell me who you think I am. The beauty of AWS Vault is that it will take that permanent credential living in your keychain, ask Amazon or AWS to transmute it into a temporary credential, and then go use the temporary credential. Another benefit is that you can start doing things like, let's say that you're rolling out those multiple roles and you don't have them right now. Right now, everything's administrator access, because of course it is.
Mm-hmm.
I don't mean that in a snide way. You're a brand new startup. It's not, don't feel bad about it. Nobody has decent access control. What you can do is you can start getting into the habit of, for example, AWS Vault exec prod deploy -- Terraform apply or whatever, right? And even though right now all of those roles are attached to exactly the same, one account, one role, one everything, down the line you modify your profile, your AWS profile. It also integrates neatly with AWS existing, it's not its own configuration. It integrates neatly with AWS's existing profile concepts in their configuration files. Down the line, you can effectively transparently, or pretty close to transparently, without having to modify what people type on the command line, introduce new roles, introduce potentially new regions, accounts, etc. And so a thing that we have multiple scripts called manage_profiles. We'll go edit that config file and modify it to be the thing that we need. And so from that perspective, as long as you regularly run that script, then your process never changes, but you just shed a ton of permissions and you had to do nothing, which is nice. I like the stepping stone.
Yeah, and especially as your team grows, it's a nice, easy ramp for them. If you get used to this tool, it's not a huge change in your process. We could probably have a whole topic almost around centralized logging, but I'm going to segue into another question. So, because we use Latacora, I've noticed in our AWS account, we have the AWS Audit role in our sort of CloudTrail logs. What do you look out for and monitor from that role?
We do two types of access, or two types of auditing. And I'm using the term, I know that we talked about SOC 2, so I'm using the term in the technical sense, I'm not using the term in the CPA sense. One is what I would call resource level, and the other is event level. So event level would be ingest CloudTrail and learn that somebody is logging in with the AWS root account or something like that. And the other one is like literally call APIs like, I don't know, AWS EC2 described instances. And the audit role is for the latter. So we use it to go call a pile of APIs, save all that information. We actually have a really cool internal tool. If you wanted to call all the AWS APIs, it's actually a graph. You can't just like call all of them directly because they all have dependencies. They have arguments that they depend on, right? So if you wanted to, I don't know, describe EC2, describe image properties, then you first need an image ID. So you have to know which image IDs exist. So you have to first call list images, et cetera, et cetera. And that goes through all of AWS. So we've got a tool that like figures that out on its own and it just calls all of AWS and sucks all that information down, puts it in a neat queryable format, and then we run queries on top of that. The reason that we have both the event side and the infrastructure side, event side is nice because it tells me when something happens, literally as it is happening. Whereas, and that's really hard to do on the resources side, right? Because you don't know when something interesting has happened in advance. But the real power comes from being able to combine them, because it's not necessarily so interesting to see, if I see a CloudTrail event where somebody's modified some particular security group, like, okay, but I need to know what's in that security group before I know if that's interesting or not. Right? Like, is that the VPN concentrator? Like, if there's a new thing in the VPN concentrator, then a group, then I care more about that than, some internal security group that's locked down anyway, right? And so we combine the information from those two places in order to be able to enrich incoming events and be able to, ask more interesting questions.
And so I guess that kind of goes into, I think, so now you mentioned in your SOC 2 blog post is that the UI in the AWS console is sort of evil. Everything should be infrastructure as code. I don't know if you actually said it was evil, but that's what I got.
There are things about the AWS console that are great. Like there's certain functionality that is either not available outside of it or is very, very difficult to get to without using the console. And so, for example, there are resources that, if you attempt to delete them, AWS will just tell you, nope. Why? I don't know. And if you go delete them in the AWS console, then it will go find all of the dependents and like actually go do the thing that you asked for. And so there are quite a few things that are significantly nicer to do in the AWS console than elsewhere. However, two problems. One, don't use the off portion of the AWS console. Like sign into it with SSO, sure. Sign into it with, so you can actually sign into it with, most people don't know this. AWS makes it sound like you've got two types of credentials. You've got the username and password, which you use to sign into the console. And then you've got the access key, which you use to call the API. You can totally sign into the console through the access key. It's just that the API for it is kind of obnoxious and you don't do it through a browser at first. And conveniently, AWS Volts is built in for you. So you just do AWS Vault, log in, name of your profile, and it will open a browser that is already signed in. It does that with AWS STS get federation token under the hood. You don't use the username, password, MFA side of things. One of the things that I love AWS to bits. I say this with all the love in the world. We use AWS internally for everything, but what the heck happened with that U2F integration? I don't know. But I'm not going to start talking about it.
So you're saying it's better to use your single sign-on provider instead of adding a MFA in the console?
Absolutely, yes. We're trying to get all of our clients to a point where there are literally no usernames and passwords attached to IAM users. You can have a username and password, but it's or you can have a password, but it's on the root user because you can't prevent that. And then we disable the root user through SCPs and all sub accounts.
A while ago, I lost one of my tokens to my AWS personal account. And so I had to go through a account recovery and I had to get my driving license notarized. And I think one of the funniest quirks was they locked my AWS account, but it was linked to my Amazon account. So just if you're ever setting up AWS accounts, don't link it to your personal Amazon account.
Yeah, so another thing that I find is one of the reasons that I tell people not to use that functionality is the ways that your Amazon account and your AWS account, like you would think reasonably that they are completely separate. And the ways that they are linked, I can only describe as arcane and eldritch and mildly terrifying. General point, don't ever, but like one of the flaws, for example, is that because you can't, which I don't know if that's the problem that you ran into, but you can only ever have one U2F key, I believe, assigned.
Yeah, I think at the time, yeah.
They might have fixed that by now. It's a mess. Don't use the front door. So a couple of things. One, there are very specific, know when you're using the console. Use it judiciously. If there's a very specific reason, I'm not saying never, ever, ever touch it. Certainly things that are completely fine are anything like once you have a read-only role, yeah, sure, use the console all you like, right? Like if you feel like the console is doing a better job of doing, describing information than what you're getting out of the API calls, great, go use the console. But ideally do it for read-only stuff. The second thing that we're concerned about is so one, if you do it with read-write, then you're basically encouraging people to use the wizard and leave a bunch of stale infrastructure behind.
Yeah.
And very often, that infrastructure is optimized for being easy to get started with. It is not optimized for being locked down. You end up with quite a bit of stale infra. And yeah, that's the other reason. Which, if you're going to have people do that, fine. But that's where the multiple AWS account recommendation comes from. Like, make sure that it's the one thing. If there was a feature that I could get out of AWS, it would be far easier account deletion. Because right now, if you're in an AWS organization, you create an account, that's an API call. Like, that's easy. It's like 5 seconds. And you got a full-fledged AWS account, it's great. But deleting an AWS account involves like resetting the root account, adding a password, and then adding a new billing account to it. And it's a whole mess, and it's a manual mess. And like confirming a phone number, like it's a whole, it's a whole thing. And if that was easier, especially for accounts that were created within the organization to begin with. Like if it was an invited account, then sure, fine, whatever. I'll go do the manual process for that. But like if it's an account that I just created, like, come on, let me delete it. And the reason for that is because like it's still annoying to have all of that like stale infrastructure floating around in your development account. So I'd rather have that gone as well. But maybe next time.
Yeah, I know. I've seen there is one project, I think it's called like AWS Nuke. That will.
So there's. Oh, sorry. I thought you were talking about. I got excited because I thought you were talking about a different project. So there is AWS Nuke, which tries to delete a bunch of infrastructure, but so many different tools. Like it has the flaw, like it's always lagging behind. And usually the infrastructure that I want to try out the most is the most recent service. So it's always the one that AWS Nuke doesn't actually work for. So like AWS Nuke is great. I'm not. It's not AWS Nuke's fault that AWS has probably launched 3 new services since we started talking. And it's been a whole 50 minutes.
In another tenant, this is PRs, protected branches, and CI/CD. And I want to kind of like segue this into supply chain attacks, which has been a hot topic of 2020. Don't even necessarily know where to start. It's such a broad topic. Just what sorts of thoughts on risks and mitigations are you seeing for supply chain attacks?
So I'll start by carving out a bunch because somebody pointed out to me recently that when we say supply chain attacks, we're typically talking about software supply chain attacks, and specifically in the form of open source software. They pointed out that I'm in the hardware business. Try and make it specific enough to be useful to the listener and not specific enough that it's identifying. From their perspective, they're like, yeah, we have supply chain attack problems, and the supply chain attack problem is like the super micro backdoor chip is what they think of when you say that. So I'm assuming that your question is specifically about software supply chain attacks.
Software,
yes.
Yeah.
For the listeners who aren't familiar, like brief summary, the idea is when you write any kind of software these days, let's say you're doing it in Node or even if it's front end, like you're relying on the NPM ecosystem, or you're writing it in Python, you're relying on PyPI, or you're writing it in Java, you're relying on Maven Central. No matter what, you're pulling in tons and tons and tons of open source software. Most of these ecosystems are subject to this kind of attack in some way, some more than others. So like, for example, I think NPM, because JavaScript has, the NPM ecosystem has this, concept of, as soon as it's left pad being sort of the example that most people make fun of, but this idea of like as soon as you got any amount of software, like the bar for creating a new package is super low, and so as a consequence, like you do React, you create your baby's first React application from a template, and you look at your transitive dependency tree in NPM, and it's something frightful. The same thing is to some extent true for Python, some extent true for Java, for pretty much everything. One big difference is that with Go, you're typically vendoring. So, like it's harder to, you're less likely to be dependent on random third party. You don't have to download the dependency all the time. But the core attack is basically somebody compromises typically the credentials of the author. Compromise can happen a lot of ways. Another way is just like I show up, I do 2 or 3 PRs in this poor anemic project that this one person from middle of nowhere has been lovingly maintaining for the last 11 years. They only ever hear from anyone when it breaks, and trillions of dollars of business is dependent on this one little project. And so this person comes along and adds a couple of really useful PRs, and they go like, "Hey, I know that you're kind of overstretched. Like, I'm happy to pick up maintainership." And now you have push rights to a repository that half the world depends on. And so the next thing that you do is you put some malicious code in there, because virtually every, if you think about it, first of all, most of these, or many of these at least, require running code on installation time. So certainly for Python, de facto, you're running setup.pys all the time. And so you could put whatever you want in there. But even if it's not installation time, it still doesn't really matter, because why are you importing the package? Or why are you adding the dependency? You're about to require or import or whatever your language calls it. You're about to run some code, right? You have that malicious code, and what happens? Well, empirically, what tends to happen right now is these are smash and grab attacks. Right? They're super broad. They're typically not going after a very specific company. They're trying to get as many AWS access keys as possible, and then they go mine Bitcoin with them. Right? Because it's it's an easily automatable way to monetize having access to a bunch of compute. But as soon as it's any more targeted than that, imagine the type of access that your median developer has in your cloud environment, and imagine what kind of damage you could do with that. And it might be pretty sizable, right? So
the SolarWinds, which was I guess they're not an open source, open core company. It just happened to be that they had a open CI/CD system.
It's a form of a supply chain attack, and this is where it gets tricky, especially in terms of remediation and possible controls. One of the first observation that we landed on is we can't tell clients, we can't really mitigate this risk on the source side. I can't plausibly look at the median React application. Most of our React's obviously super popular. Same is true for among our customers. And I can't tell a customer hey, nice NPM dependency package tree you've got there. It would be really great if there was 10% of the dependencies in there, because that's just not how it works. You basically told them that their app isn't allowed to exist, right? And so you can't really, you can. There are ways that you can mitigate, there are unforced errors there. You can kind of chip back at that a little bit and identify, for example, packages that relatively few maintainers, or relatively under-maintained, or have a lot of inverse dependent, have a lot of reverse dependencies, that sort of thing. You can do some graph analysis on that and try to identify particularly risky packages. But for the vast majority of the time, you're not depending on a particular package because you really want to, right? The vast majority of packages are going to be in the transitive tree, where you're dependent on them because someone else is. So the way that we've approached this problem is we started looking at what are attackers actually doing when they get these creds, and how can I mitigate that? Because the problem is you can't really do it from the source side. You can't really significantly put a dent in the number of dependencies that people have, particularly so I would say for the NPM ecosystem, because a lot of people, they look at their transitive dependency trees and they haven't heard of the vast majority of packages in there, right? Because they're not pulling it in. Bobble is pulling it in, or they're not pulling it in. React is pulling it in, possibly transitively itself. Can't really tell them to try and make a dent in that set of dependencies, because you basically just told them that their application is not allowed to exist. There are places where we might be able to do that, and usually it's combined with some other form of risk mitigation to warrant the amount of effort that it takes to remove a dependent, because you're depending on this for a reason, right? You're gonna presumably you're calling it a bunch of times, and so we do stuff we're working with a company that is doing graph analysis on the open source database side. So they're looking at things like what are packages that have relatively few or relatively many reverse dependencies, relatively few maintainers. What are some of the other indicators of potential problems with that package, code quality issues, et cetera, both from us. So they're attacking it from a supply chain perspective, both in the software supply, the open source software supply chain attack vector that I mentioned, meaning somebody gets maintainer access to a critical package and starts pushing malware through that channel, but they're also doing it through what are the odds that this packet is going to have significant vulnerabilities in it, or is it just going to break all the time and is going to cause damage that way. There's a company called Phylum, Philum. They're very early on, but they're doing really, really cool work. I'm really excited to be working with them. So you get that like information about sort of like a package score effectively, right? Like how bad is this package and why? And that could be, licenses, could be code quality, could be questionable maintenance. But you also have to combine that with, or we do typically with other risk factors like, hey, you're running inside your Django web application that is responding to all of these other requests. You're also doing, I don't know, like image resizing or something. And like, how much do I trust that image parser? Not a ton, especially when you're directly feeding it attacker control data. One approach to that is go find me a vuln, but that's a lot of work. So the other approach to that is, how about we put it in a Lambda that has no permissions and gets called with a pre-signed S3 URL. So it literally has an empty role. And, then, sure, maybe something gets remote code execution. Congratulations. It's remote code execution in a completely uninteresting part of the application. Bottom line, I don't think that really getting the set of dependencies down is going to be, like, it's never the entire answer. It's an important part of the answer. And when there's enforced errors, you should go attack that. But it's not a complete picture. That's where stuff like, for example, AWS Vault comes from. Or the OpenSSH, we did a blog post about OpenSSH keys and their password protection. That's where that came from as well. So we started threat modeling like, okay, well, let's assume that's a given that there's going to be a dependency. It's going to get popped. We're not going to know which one it is in advance. There's nothing that I could do about it. I can't prevent the problem from happening because I would basically be prohibiting React or Django or some other, extremely common package. Where do we go from there? Like, what do we do after that? And AWS Vault is a perfect example because we don't have to guess what people do when they get these creds. When they get remote code execution, they're stealing AWS and GCP creds, right? And they're using them to mine cryptocurrency. So, then from there we started thinking like, well, what else could I do? And SSH keys is a big one because that's how I would get persistence. GitHub as SSH key based auth. So I don't have to know what your GitHub username is. I can just ask GitHub. And so, that's what I would do. And that's where we started, where I went down the rabbit hole of figuring out how the heck password encryption worked for SSH keys.
For people aren't familiar, so you had this blog post and it kind of stuck in my mind too. And it said, it went over the sort of default OpenSSH key encryption, but you also said that adding a password is worse than not having one. I just wonder if you can explain why adding a password is less secure.
For what it's worth, I think that it's true, but I will admit that was a little, there's a reason it was in the title and that was clickbaity. And I'm not ashamed of that at all. Basic story is that to OpenSSH's credit, I have no idea if they did it in response to the blog post, but when we posted it, the next release had the default key format be one that does not have the flaw that I'm about to describe. Good for OpenSSH, and good for all of us. Regardless, so the flaw is if you had a key, typically an RSA one. So you'd have the public key and the private key, and you've presumably most people who've used SSH know about that because you've had to go get ID RSA.pub from your home directory and then go save it into GitHub or whatever. You have the private key, and that private key is typically password protected. And in the old format, that password protection was not great. It was MD5 over the password. And so as a consequence, it's reasonably easy to enumerate. So it's unsafe for the same reason that it would be unsafe to use MD5 as a password hash in a database. So you would simply enumerate every possible password, run it through a fast GPU that does, a couple of gazillion MD5 guesses per second. And then you would, before you know it, have the actual password. The reason that I said that it's worse than plain text is because, at least at the time, and to some extent this is still true, plenty of people were upgrading. Let's say if you're on macOS, you were getting your SSH from Homebrew. It wasn't integrated into the OS keychain. If you were using keychain, it was fine, right? Keychain doesn't have that flaw. You'd be typing in your password all the time into something that would unlock when keychain unlocked. And so it would be a password that you would type all the time. And so you would, of course, reuse it because why wouldn't? What other password do you use? You're going to use your desktop password. And so we validated that. We asked a bunch of people and they were like, yeah, that's definitely what I did. Like, I'm not blaming anyone. Like my absolutely my SSH key password was, I was expecting it to be the same thing as, like, I was expecting to unlock it with keychain, right? Like, it's not, like that smoking gun admission. So the problem with that is that it is much easier, like I can't brute force your password against keychain, right? Because keychain is hardened against that sort of thing. But I can absolutely brute force your password against your private key, because that's, it's crypto. Like I don't, it's not software. Like I can just try as many ones that I can asynchronously as I want asynchronously. And so the idea is that basically it produced an alternative route to be able to guess people's passwords that was significantly more performant than any other such route. Whereas every other system, like, I don't know, 1Password or your keychain or Chrome or whatever it is going to be built. I mean, Chrome often by virtue of using keychain, but you know what I mean? They have password guessing as a threat model. They're going to use better password hashes. They're going to use something like an Argon2 or whatever, or PBKDF2, or they're going to use, hardware-backed cryptography, like in the case of your phone, typically, or a combination of both.
Moving away from, one thing I remember at Rackspace was you'd always introduce me to lots of sort of cryptography basics, and I feel within the time, the space of cryptocurrency is also sort of blown up, and it's always like an interesting cross-section of distributed systems and cryptography. Like, what do you think we can learn from this ecosystem?
It's a very challenging question, and I'm glad that you asked it, because it forced me to kind of like not just be a pure cynic, because it is no secret that I am no fan of cryptocurrency for a variety of reasons. But right now, the absolutely absurd energy usage of Bitcoin is certainly near the top of the list. But to your point, it did. There are a lot of fantastic things that came out of it. A couple that came to mind is certainly the number of cryptographers. First, people who became cryptographers. And then second of all, cryptographers who were gainfully employed doing really cool cryptography research. And like, yeah, sure, they were doing it for cryptocurrency, but like a lot of the cryptography research ends up carrying over, particularly some of the, like a lot of the modern work into signatures was prompted by requirements of fancier crypto schemes, which tended to be cryptocurrency. So like, I don't necessarily know for a fact, like I don't have data to prove that, cryptocurrency funded specific types of research that cryptocurrency paid for. But, I think it's pretty fair to say that cryptocurrency is the 500-pound gorilla in the room there. And so all sorts of really interesting crypto research, I think, being paid for by two things, cryptocurrency and Google, seems to be the summary. And that's not fair. Google is doing a lot of really cool practical applied crypto research. So is Microsoft, or at least Microsoft Research, which is a reasonably separate arm. For me, it would have to be like a lot of advances in zero knowledge proofs, which recently I had a pet project that I'm not quite ready to lift the veil on, but I had a pet project required a designated verifier zero knowledge proof, which, did it exist before cryptocurrency? Yeah. Would it be as broadly available, and would I probably have thought about it if it wasn't for cryptocurrency? Probably not. And I think the same thing is true for like certificate transparency. Certificate transparency is this project by Google where the mission is, what if we captured every TLS certificate that was ever created that anyone ever saw? We're going to put them in this big tree, and we're going to make sure that the tree is designed in such a way that's nice and efficient. But the consequence is that you can't present a certificate to your browser without having publicly committed to that certificate. And that, for example, addresses issues like, any kind of misissuance. So like it could be like a relatively benign, like, a CA screwed up by, I don't know, issuing a certificate with the wrong duration or something. I say relatively benign because the really bad failure mode is, oppressive regime tries to impersonate Facebook. Or tries to impersonate, another critical service and uses it to actively hunt down journalists. Like that's, a not before and a not after being minted for the wrong time. That's certificate transparency. Is that a consequence of cryptocurrency? No. All the tools, like first of all, it's not solving a Byzantine consensus problem, right? Like it's not proof of work or proof of stake or whatever. It's Google is gonna. Most of them are operated by Google. Google signs stuff, and you do it because Google says so. It's single writer, but I think that people wouldn't have been thinking about but it looks like blockchain, right? Like because every entry references the previous entry. I don't think that people might not have thought of that if cryptocurrency hadn't been taking up so much headspace. As much as I'm generally not super excited about cryptocurrencies, or at least, have some questions. It is absolutely the case that they've funded so much cryptography research, and a lot of it's pretty practical. Some of it's a little out there, but good for them. Like I'm glad people will get a chance to work on it, and what used to be a purely academic field, and now you don't have to go into academia.
Thanks, that's a great answer. Talking about just cryptography, I have a great ebook called Crypto 101, which is sort of a introduction to sort of cryptography basics for, I guess, like application developers. You presented at PyCon. Published this in 2013. If you were to make a revision, what would you add or remove from this book?
First off, we've been adding parts to the book since 2013, so it has gotten a decent chunk of revisions. If there's specific things that I'd add, so the structure that Crypto 101 takes is it starts from the minimum viable primitive that we can talk about, literally an XOR gate, and then kind of walks you all the way up to TLS and talks about all of the primitives along the way that you needed in order to get a real crypto system, like a real useful crypto system, TLS being kind of like the ersatz for everything else, partially because it's got kind of everything in it, right? Like it's got block ciphers, it's got authenticators, it's got signatures, key agreements, the whole 9 yards. And what's still missing now, like all of the attacks are cryptographic attacks. They're direct cryptographic attacks. You've got unauthenticated CBC. Let's do a bit flipping attack, and then let's expand that into a padding oracle attack. And those are cool. Those are useful. One, I would add a couple of attacks that currently aren't in there, but I think are really cool. Mostly, I haven't added them because they're pretty complex, and I like the fact right now that Crypto 101 is sort of like very upfront about like you need like middle school level math at most, and most of the time not even that, right? And some of the more attacks that I think are really interesting that I kind of want to add are like I feel like they would come with a little bit of a warning, because I don't want people to feel stupid because they just like haven't seen a particular math thing, right? Like it's still not complicated, but I find that math scares people. Is kind of the point. And if you're there to explain it, then that's fine. But if it's a book, it's kind of static, and I don't want to dissuade people. But the two attacks that I would add is ASGCM truncated tag attacks, where basically like if you ever use a truncated tag, like the total security of GCM against forgery is like whatever the shortest tag was, which is very, very surprising to a lot of people. There's all sorts of cool attacks on GCM that I think people don't like, because it's the good crypto system, right? Like it's the one that you want. And most of the time it is, but it's also kind of dangerous, and it's safe in the very specific ways that we use it in TLS. A lot of elliptic curve attacks, because I don't think I've ever added, like, for example, off-curve attacks. I think I might have described that one. I forget if it was in the blog post or if I actually added that book, but that one. So there's a couple of like fancier crypto attacks that I'd love to write up. And then the second thing that I would add is protocol design, and the way that I currently build up from cryptographic primitive to primitive to primitive to primitive, building up, ending at TLS. Do that, but for once you've got all of that, build a protocol, end at noise, end at the noise protocol suite, and go through things like key compromise impersonation and stuff like that.
So moving on, kind of like getting towards the end. So you're both a fellow of the Python Software Foundation and a co-founder of Clojurists Together Foundation, which, obviously two different programming languages. How do you use a programming language when you think of a problem, how do you use a programming language to solve it?
Super easy. You start, you pick Clojure, or you make a mistake. It's fine. Jokes aside, I do like Clojure. I like Clojure quite a bit. Case in point, to your point, I do a decent chunk of work, funding the open source ecosystem for it. Do you mind if I rephrase the question and aim it at like clients? Because then it's not my weird proclivities. It's like, what should people who are listening to this do? And the answer is, of course, use Clojure. Where are you paying attention? There's a lot of really good choices these days. And I think that for the vast majority of applications, there's honestly, if you're using a halfway modern framework, do whatever you want. I don't think, so people have asked me that question in terms of like, well, what should I do if I want to write secure code? Should I write Python, or should I write Ruby, or should I write?
I think I'd Rust was my follow-up question.
Don't get me wrong, I love Rust. I think Rust is fantastic. It's one of the things that I'm most excited about, like, being able to put a dent in the long tail of gnarly C libraries that everyone depends on. But for our clients, I don't know that they're like the vast majority of our clients are like they're B2B SaaS companies. And I think that there's safety gains to be had from Rust. Yeah, but realistically, their alternative wasn't C, right? If their alternative was C, then I would go, yes, definitely go write it in Rust. Do not write C. Do not write, C++ either. Stop telling me how, if I have to hear one more time about how modern C++ is basically the same thing as Rust, then I'm just gonna, I don't know, I'm gonna take a Sharpie, or like I might actually like write a counterexample in blood. Miscellaneous C++, terrible C++ misfeatures that people use all the time. Am I excited about Rust? Yeah, I'm excited about Rust for replacing like parts of the Linux kernel. And I'm excited about Rust for replacing, and same thing for iOS. I'm excited about, I guess they're more likely Swift, but Swift, sure, great, right? Like I'm excited about memory safety.
Yeah.
For the long tail of things that aren't memory unsafe, but like most of our clients, like they weren't going to use C, they were going to use Python, right? And like if you already have like a Python, like a Django web application, like a Django REST framework or something, I can't see a super compelling reason for you to go rewrite that in Rust. It's not that I think Rust is bad. It's just like I don't think Rust gets you anything.
It's the right tool for the job.
Exactly.
And I guess if you're in the business of CRUD, stick to something that makes it easy to create forms.
And that might be Rust, right? Like I'm not saying not Rust, right? Like it's fine. I'm just saying don't rewrite it. I don't think it's like if it's buying you something, like if you feel, for example, hey, my application has a bunch of state machines. And I am much more comfortable if I can express those in the type system, and the Rust type system is way better at expressing this than Python. Then go hog wild. But it's just like I can't remember the last time that we actively found a memory corruption vulnerability that was exploitable in one of our customers' apps. And every time that we found it, it was the way that we told them to prevent it wasn't go rewrite the entire thing in Rust. It was go take this tiny piece of code I mentioned earlier with the Lambda, go take this tiny piece of code, go run it somewhere else where it can't do any damage. Because realistically, like you're not going to, re-implement libjpeg, right? Like you're just going to keep doing what you're doing. And it's also a question of like how much effort is it, right? Like if you're going to rewrite the entire app in Rust, that's quite a bit of work. Whereas take this piece of code that you've already written and literally just like rip it out and put in this other Lambda, like it's not trivial, but it's plausibly a day's worth of work, right? Like it's not that bad.
During our time at Rackspace, you always had a good pulse on the latest tech and security tech. What's got you excited recently?
I feel like depending on which security person you ask, which might be just the same person but on different days, you're either going to get like a horribly cynical answer where it's turns out I've convinced myself I've got job security for the next 100 years.
You moving to the woods,
or it's bright shiny. I'll tell you what I'm excited about, but it's not necessarily an endorsement or a counter endorsement for that matter. It's just a very me being very cognizant of. Just because something is exciting to me does not necessarily mean that it's like the most useful thing for anyone to go deploy tomorrow. I do get excited about sort of like, the little wins, right? Like the every time that we can figure out a way to make, our IAM minimization strategy slightly easier to get started with. Like we talked about AWS Vault. Like I love that entire document because it just like, it's so easy to get started. And like the material real world impact of that has been so much greater than if I just like described what the beautiful end state, eschatological version of that is. I try to be excited about, the little things like, I'm doing a lot of AWS IAM work recently. That's why I keep talking about AWS IAM. In terms of things that I like, every time that I play with them, I am reminded that the world is full of beauty. I had a reason to play with the Linux perf subsystem and eBPF the other day. Most of the time don't get an opportunity to use it because we're running on like highly restricted environments like Lambda and Fargate, which most of the time absolutely the right call for us. But it's still cool to be able to play with those. I am super excited since we talked about Rust earlier. Yeah, like Rust in the Linux kernel. I am super excited about cutting down the number of places that I have to care about code execution within the kernel. I don't know, other things that we've been messing with recently, talking about kernel exposure, gvisor. So gvisor is a user space program by Google that basically emulates portions of the Linux kernel API. So like you make syscalls into gvisor instead of making syscalls into the Linux kernel. That's really cool from a sandboxing perspective. Like that has all sorts of great advantages. So I'm kind of excited about that, but it's a niche application, right? Like there's a lot to be excited about. Most recently, here's one that's applicable to a lot of people. GitHub Actions. If you're using it with AWS, we could put a link in the show notes, I assume. So recently they made it possible to directly integrate between GitHub and AWS so that you could assume a role directly instead of needing to like save an access key in GitHub secrets. Because like, come on, it's a matter of time before that's going to leak somewhere. Like it always, I mean, I'm sure it's safe, but like it always gives me the heebie-jeebies when there's a system that has like, because also it has like admin access half of the time, right? Because like people are using it to deploy infrastructure and stuff. So it's like it's not a mild cred, right? Like it's star. But yeah, a lot to be excited about. It's hard to pick.
Cool, that's great. So just closing up, what are your top 3 lesser known tips to stay secure?
So my 3 favorite ones, I mean, we talked about a bunch of them already, but certainly AWS Volts. Like it's hard to oversell, I think, AWS Volts for how easy it is and the return on investment you get from it. WebAuthn and U2F keys, which again, I imagine most of your listeners are maybe not that unknown, but it's just the reason I bring it up is like AWS Vault, just the ruthless efficiency of it, like the number of attacks that are completely irrelevant because like, Google has come out and said phishing is dead. We've killed it. WebAuthn did it. Like we're good. The third one, that one I'm gonna have to think about. But I don't know. Maybe next time.
Maybe next time. All right. Well, thank you so much for your time today, LVH. I've had a great time with you.
Likewise. Thank you for having me.
This podcast was created by Teleport. Teleport allows engineers and security professionals to unified access for SSH servers, Kubernetes clusters, web applications, and databases across all environments. To learn more, visit us at goteleport.com.